Hello friends, in this video I'd like to solve the following problem from the Romanian District Mathematical Olympiad for 12th graders 2022, problem number 1. Let M be a monoid and let A be an element of this monoid, which is invertible. And let's consider the following set. M sub A consists of all the elements x of our monoid such that A x squared A equals 1. By 1 I mean the neutral element of our monoid. We wish to prove three things. A. This set M sub A is non-empty. B. If B is invertible, then B inverse is in MA if and only if A to the fourth power equals 1. And finally, C. If MA is a monoid, we wish to show that x squared equals 1 for all elements x of our set MA. So here are my hints. This problem is relatively easy. For part A, to show that our set is non-empty, show that A inverse is in MA. B. Notice that saying that B is in our set MA is equivalent to saying that B squared equals A to the minus second power, which makes sense because A is invertible, so it makes sense to raise it to the minus second power. And for part C, notice that since our set MA is a monoid, then what exactly? Then we have x is in MA, then x squared is in MA, and show that x to the fourth power equals a to the minus second power, which equals x squared as well. So x squared is invertible, invert it, and you will get the result which you want. So give this problem a try, and I will see you in just a minute. Alright, so let's start with part A. Part A, note that A inverse to the second power A, it's A inverse A. We can group it in any way which we wish because our operation is commutative. So it's 1 operation 1, which is 1, which means, so A inverse is in MA. In particular, it is non-empty. Alright, part B. Notice that notice the following. B is in an MA is equivalent to saying that A B squared A is 1, but remember that A is invertible, so we can invert it. So we can put A inverse, A inverse, A inverse, A inverse. And this is equivalent to saying that B squared equals A to the minus second power. Alright. Now, the following will be equivalent as well. B inverse is in MA. It is equivalent to saying that A B to the minus second power A is equal 1. Again, the same trick, we'll take A inverse on both sides. A inverse A B to the minus second power A equals this. And this is equivalent to saying that B to the minus second power equals A to the minus second power. Alright. But now, what now? Notice that this means this is equivalent once again to saying that B to the second power equals A to the second power. Why is that? Well, because I'm just inverting everything. I'm multiplying both sides by A squared and B squared. Alright, but now let's compare it. B squared equals A to the minus second power, and the same B squared equals A to the second power. Which means this is equivalent to saying that A to the minus second power equals A squared, and after taking A squared on both sides, 1 equals A to the fourth power, which is exactly what we wanted. This is equivalent to this. And finally, part C, what we wish to show is that x squared equals 1 for all elements of our set MA, provided that it is a monoid. So let X be an element of our set MA. Since it is a monoid, we have also that x times x, which is x squared, is also element of our monoid. Alright, but now, what does it mean? Notice that x is in MA is equivalent to saying that ax squared a equals 1, and this is equivalent, once again, to saying that x squared equals a to the minus second power, and x squared is in MA. This is in turn equivalent to saying that ax squared, which is ax to the fourth power, is 1, which is equivalent to saying that x to the fourth power equals a to the minus second power. Alright. Now, but also notice, for example, this is equivalent to saying that a squared x squared equals 1. Alright, now let's compare these two lines. X squared, we see, equals x to the fourth power. X to the fourth power equals x squared. And I will take this very line and I will multiply by a squared on both sides. And also, I will write x to the fourth power as x squared times x squared. And now notice that a squared x squared, it is 1. So we have just x squared equals 1, which is exactly what we wanted to demonstrate. And this closes our entire proof. Thank you very much for watching. I hope that you've learned something new this time, that you have enjoyed this problem, and I will see you next time. Goodbye.